Hello. A little bit of background. I'm Nick. I run a company called Domino Data Lab. I started the company about 10 years ago. Zetta was our first VC investor. In the last decade, we've built the most complete, most advanced platform for helping enterprises build and operate AI at scale for mission-critical use cases. So we work with the biggest banks, pharmaceutical companies, defense organizations in the world. And one of our core guiding beliefs throughout our whole journey has been that data science work is a unique discipline of work. It's not the same as software engineering. It's not the same as data engineering. It has its own idiosyncrasies. And so we've been obsessed with this idea of how do we build tools and products that are purpose fit for the unique requirements of doing data science work. And we're at an important moment now, I think, to remind ourselves of that uniqueness of data science work because, is this clicker working? Okay, there we go. Because everyone is obsessed with coding assistants. And coding assistants are a great way for software engineers to become more productive. And so, the rage right now is it's all vibe coding. Everything everywhere is going to be vibe coded. But it's important to step back and ask the question, how does this work for data scientists? How does this work for data science work? And the reality is it's helpful because programming is a part of what data scientists do, but programming is by no means all that data scientists do, and we can do a lot better for data scientists than just merely vibe coding and coding assistants. Three reasons for that. The first is that while programming is one part of what data scientists do, their workflows involve a lot of other things. They do asynchronous experimentation with long-running compute tasks. They have to deal with that and make that work. They got to do infrastructure configuration. Their workflow is highly iterative and experimental. They need to go find data, et cetera, et cetera. The second point in the middle of the slide, this is really important. With software, if you have a working product at the end of the day, it doesn't matter how you got there. That's not the same with data science because data science is research, and especially in a regulated environment, what you tried and why you made the decisions you made along the way, those things matter as much as the final product itself. And that brings me to the third reason, which is, again, in an enterprise setting, compliance is not copacetic with vibe coding. You can imagine being at a bank and telling your internal model validation team that this new lending model we've got, we did it so quickly because we vibe coded it. That doesn't fly. So things like sort of lineage, reproducibility, auditability, how you built the thing you built, how you built your model, these are all critical. And so what I want to show you, I want to give you a vignette of kind of how we've been thinking about approaching this problem, what we see as the future of productivity for data scientists. We built what we call a modeling assistant. It's a little different from a coding assistant, but it works with coding assistants. So we said, we want data scientists to be able to use their preferred IDE of choice, their preferred coding assistant of choice, whether that's Cursor, whether that's something in Copilot, whatever. But what we did is we exposed as an MCP server a bunch of tools that can be used as tasks to automate tasks in a data science workload. Things like running a model training experiment, things like finding data, things like writing model documentation. And we've backed the implementation of all those tasks with our platform, which I won't go into a ton here, except to say our platform, Domino, automates a lot of these common data science tasks, but it does so in a way where it provides out-of-the-box automatic reproducibility and auditability. So every action that's run, everything a data scientist does is going to be tracked as an immutable history in a reproducible record. And so what that means is that data scientists can now ask assistants to do broader, more open-ended modeling tasks for them, and the history and lineage of everything that goes in along the way will be preserved automatically. I'm going to show you a quick demo. The demo was, this is not cherry-picked. This is like real usage of this assistant. This has been some editing for brevity. And of course, because we're at an AI conference, the narration is all an AI-generated voice, I think, through 11 Labs, I think. So here we go. Let's take a look.
I'd like to show you a quick model training and optimization use case using the Domino Modeling Assistant. We'll do this with Cursor's agent, connected to Domino's platform API using our MCP server. We're going to work with a simple CSV dataset to train our classification model to predict diabetes with a simple set of features. Here you can see the diabetes model architecture, a simple 4-layer neural net with hidden dimension sizes that are configurable. Our training script defines a typical training loop for this model and runs from the command line with arguments for setting typical parameters like number of epochs, batch size, learning rate, and the model size. I'm going to use a simple prompt to ask the model to understand our training script and optimize the model through a few training attempts. Because of cursor rule settings, the model will automatically run tasks on the Domino platform using the MCP server tools available to it. We're using Claude 3.7 thinking here, and it first reads the training script, the model architecture, and the Domino project settings. After verifying JIT is synchronized between our IDE and Domino, it runs a Domino job with a first training attempt. 10 epochs, 32 batch size, a small model, and 0.001 learning rate. After checking that the job is completed, it retrieves the results, and here you can see that it sees we've achieved a decent accuracy of 96%. It also opens a web browser showing the specific experiment run that was logged on Domino from this training attempt. While we're on the Domino UI, we can see here that Cursor ran the training like any other Domino job, meaning it's tracked and fully reproducible by any project collaborators. Okay, so Cursor has decided it's going to make another training attempt. This time, slightly more epochs, a bigger model, and reduced learning rate. I've zoomed in to show you we're getting a higher accuracy on this second attempt. But what's cooler is that Cursor has decided it's worried about overfitting and is proposing to make a code change to the model architecture to increase the dropout rate slightly. After checking the results of this third run, Cursor has decided to make one last change to our model code, adding weight decay to our atom optimizer. Checking the results of this final Domino job run, Cursor is providing a nice summary about the training run attempts it's done, and has concluded the final attempt is a good enough model candidate at over 97%. The key thing is everything we've done here is fully tracked and reproducible from the Domino platform. Our modeling assistant is a safer and more maintainable way to use AI agents in your ML development workflow.
What do you guys think? Data scientists in the audience? It's pretty cool, right? Okay, thank you. And the best thing is that not only are the data scientists more productive, but the compliance teams are happy. And we're really excited about what we think this is going to unlock for the future of innovation among data scientists. And really appreciate you guys taking time to watch and listen. Thanks.